ಆಮೇಲೆ ನೀವು ಹೋಗ್ಬೇಕಾದ್ರೆ ಸ್ಟಾಪ್ ಮಾಡ್ಬಿಟ್ರೆ ಸ್ಟಾಪ್.
In yesterday's class we saw one of the examples momentals based on our transformations. Let us continue a few more examples today. Especially in this subject, we are supposed to solve as many examples as possible, because every individual can have it their own circuit. Only thing is, the concepts must be very clear. Okay. Note down the problem statement. For the network shown, calculate the equivalent resistance. Calculate the equivalent resistance across terminals A and B. Across terminals A and B. Fine.
Sir, you are not audible, sir.
Now, this is clear.
Sir, once repeat the question, sir.
For the network shown, calculate the equivalent resistance across terminals A and B.
Okay, sir.
Look, in the problem statement, they have not mentioned any kind of technique. I mean, which technique you are supposed to use. They have not mentioned it. Right? But in the previous examples, they have clearly mentioned to use particular technique, that is started transformations, right? Or source transformation or source. In such cases, the very first step is to identify any series combination of resistance or any parallel combination. If it is so, if there are any series resistors present in the circuit or parallel combination of resistors present in the circuit, straight away we can reduce it. Okay? Straight away we can reduce the series connected resistors and parallel connected resistors. But in this example, right, but in this given network, is there any such series combination of resistors or parallel resistors?
No, sir.
Will you find any? Yeah, there is no series resistors, correct? So ultimately, across the A and B, we are supposed to have one equivalent resistor, only single resistors, instead of having this complicated network, correct? Connected in some delta star fashions. It is a resistive network. Fine. Now the very first step is to identify those series and parallel combinations. So we are unable to find it. So the next step is to look at star and delta combinations. ಎಷ್ಟು star connected networks ಇದೆ ಇಲ್ಲಿ, and how many delta connected networks are present in the given network? Can you identify? Those 2 ohm resistors, correct, will form a delta combination. So the inside.
Yes, sir.
Inside 2
Yes, sir.
ohms each, yeah, forms a delta network. And one more delta network I can identify. That is the outer one. Outer one, 2 ohm, 2 ohm, and 2 ohm. That also forms a delta network. Correct, right? There is no one second. Okay. So we need to identify one delta network that if I transform the delta network to star, we need to see that is there any reduction possibility available after transformation. If I transform this inner delta, right, network to star like this. So you need to analyze it. Analysis is very important. So what I get if I transform this inner connected delta to star, then this 4 ohm resistance will come in series with this branch. Correct? Also, another 4 ohm resistance will come in series, so that there is a reduction possibility. So let us do it. Let us convert or transform this inner delta to star. So to convert delta to star, right? How to convert delta to star? If I want to know this resistance value, right? If you want, you can draw a circuit like this. Only this is required only during the starting stages. Once you get familiar in applying these transformations very frequently, right? No need of drawing these things. We know delta is that is 2 ohms. Hey, who is that? Huh? ಸರ್ ಇಲ್ಲಿ ಕಾಣುತ್ತಲ್ವಾ ಯಾವ ಚೀರಾಡೋದೆಲ್ಲ ಕಾಣುತ್ತಲ್ವಾ ರೆಕಾರ್ಡ್ ಆಗಿರುತ್ತೆ ಓಕೆ ಕ್ಲಾಸ್ ಡಿಸ್ಟರ್ಬ್ ಮಾಡೋದು ಬೇಡ ನೋಡೋಣ ಯಾವನ ಚೀರಾಡ್ತೀವಿ ಓಕೆ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ delta to star 2 into 2 divided by sum of all 4 divided by 6 ಎಷ್ಟಾಗುತ್ತೆ ನೋಡಿ 2 by 3 2 by 3 value is
0.66 ohms. 0.66.
its value is 0.666 ohms. Since all the resistance values are same, delta connected, all resistance values are same, I get all the same values because even to calculate this particular wing of the star network, again, product of side impedance, that is 2 into 2 divided by sum again remains, the denominator remains same. So again I get 4 upon 6, which will result in 0.66. So all the 3 branches of star network values are same. This is because delta connected network has equal, same value. Now I'll try to redraw it. I'll try to redraw the network. So this 4 ohm will come in series here like this. So this is the transformed network. Right? Delta to star. Now these two are in series. 4 ohm and 0.66 ohms are in series.
Series.
Simplified. So it becomes 4.66 ohms. Okay. Can anyone Tell me what can be done in the next step in order to reduce the network further. Again, I don't find any resistors in series or parallel again in this network, right? In this redrawn network. What I should do is, if I transform this inner star to delta once again, right? Like this. Inner star to delta. Then I get two delta connected networks in parallel. Correct? Huh? When two delta networks are in parallel, it will result in single delta. Yes. So transform the star to delta. Star to delta. After transformation, you get circuit like this. After transformation from star to delta, what will be the value of this branch? Product of sum of all the three divided by opposite. One value can be tried because even all these branches are having same resistance. So it will be same. Next one is product of sum of all the three upon opposite resistance. 4.66 into 4.66 plus again 4.66 into 4.66 plus 4.66 into 4.66. Upon opposite resistance is 4.66. Next one is
13.98 ohm.
13.98 ohms, correct. 13.98 ohms each. Or now look at this. These two are in parallel. These two are in parallel. These two are in parallel, which will result in single delta. Okay, do the parallel combination. Simplify. 2 into 13.98 product by sum. 2 into 13.98 upon 2 plus 13.98. Let's start with that. .75 and correct. Is it? Just to parallel combination. If two resistors are connected in parallel, their equivalent resistance is simply product upon sum. Simple as that.
0.74, sir.
Huh?
1.74.
1.75 ಬರುತ್ತೆ ನೋಡಿ.
1.749.
Yeah, 1.749 approximately.
1.749.
5. Yeah, approximately 1.7. Since all the
Yes, sir, 1.7.
branches have same value, you got the resistance of something delta. Okay. See, from where to where we have simplified. Earlier, the circuit was looking very complicated, right? We have star and delta combination of resistive network. Only we applied 3 transformations. Have reduced network to a single delta. As we are interested in finding equivalent resistance across terminals A and B, these two are in series of the lead. The combination of this, the combination of these two resistors connected in series is in parallel with resistance at terminal A and B. So, if it is A and B, it is 1.7 1.75 resistors between A and B, and these two are in series. So yeah, 1.75 plus 1.75. 3.5.
Yes, sir.
3.5. Now these two are in parallel. 3.75 ohms as well as 1.75 ohm are in parallel. This is the last step. We are at the solution. This is the equivalent resistance across terminals A. Here at 3.5 to 1.75 upon 3.5 plus 1.75. 1.16 ohms. Therefore, equivalent resistance across terminals.
1.16, sir.
1.16.
So together, how many transformations we have done? First one, inner delta, we have converted that to star. Then after converting that to star, we got some series resistances. Right? Simplifying that, we got see, everything will be recorded. Right? You'll come to know who is doing nonsense in between the class. Once you come to college, I'll kick you, man. Useless fellow. If you are not interested, you just sign it off. Okay, once we simplify that series combination of resistors, again we applied one more transformation, that is now star to delta, which made, right, two delta connected networks in parallel. So that parallel, if two resistors are in parallel, again we found an equivalent resistance of these two delta connected network will already have resulted in single delta network, where again, since we are interested in finding resistance across two terminals, so it is assumed that the third terminal is open. So when it is open, no element or branch is connected to this junction, hence these two are in series, which will come in parallel with resistor across the branch A. Hence we got the solution, that is R equivalent as 1.16 ohms. Okay. One more example. Let us do one more example. So the same network was appeared very often in the university paper, university question paper. You can mark it as an important problem. The same network has appeared for many times in the exam. They ask you for 6 marks or 8 marks. Note down the statement. Determine current through 10 ohm resistance for the network shown using star delta transformation. Using star delta transformation. So where is the 10 ohm resistor? Here. So we are supposed to calculate current flowing through it.
Sir, can't see, sir.
Continue. Network.
It's okay, sir. Now
No?
it is visible. Yeah, sir, yeah.
Okay, note it down first. Note down the circuit.
Yes, sir.
As I told you in the previous example, the very first step is to see are there any resistors in series or parallel before applying starting. Looking at this circuit, these two are in series, correct? This 8 ohm resistor and 4 ohm resistors are in series. Also, this 13 ohm resistor and 17 ohm resistors are also in series. So straight away we can reduce it, right? By adding it. Instead of having two resistors here, 17 plus 13, I will replace with 30 ohm resistor. Okay. Even here, 8 plus 4. Instead of having two resistors, I will replace it with one single one of value 12 ohms. Now, is there any possibility of series and parallel? Are you able to find any series combination of resistors or parallel combination of resistors? No. Okay? Now let us apply star delta transformation. So this is one pi connected network. This is pi connected network. This is also pi connected network. Okay. So how to simplify? How to convert that pi andre delta? How to convert that to star? So 2 delta connected networks I am trying to transform to star. So again, I'll try to redraw it. Start the network. Okay, this is 24 ohm resistor. And here is a lemon where we are interested in finding current flowing through it. There is a voltage source of 180 volts. Okay. Now let us evaluate this star connected resistors using delta to star. Can anyone tell me the value? If you evaluate one single wing of star, the remaining two wings of star will be same because all three resistors of delta connected are of same value. ಎಷ್ಟಾಗುತ್ತೆ?
4 ohms.
12 into 12 upon, yeah, 4 ohms are correct, 4 ohms. Since all the values are same, I get all the branches of star network resistor values as same of 4 ohms. Fine. Even here, I've transformed delta to star.
10 ohms.
10 na?
Yes, sir. 10 ohms.
Yes, sir.
Correct, 10 ohms. Correct. Eager nodi, is there any series resistors in this network? Of course, we have series resistors. Right? Once you do transformation, once you do transformation, definitely there will be a reduction possible. So this 4 ohms, 2 ohms, 24 ohms, and 10 ohms all are in series. Correct?
Yes,
All
sir.
three resistors are in series. Also, this 4 ohms, 10 ohms, and 10 ohms are in series, but I explained you even while learning the concept of source transformation that wherever they ask current through element or voltage across element, that particular resistance must not be considered for simplification. Correct? I have repeated this same
Yes, sir.
statement many
Yes,
times. Yes. So I don't consider these resistors for simplification purpose. But I know that even if I consider, there will be no effect in current because all the three resistors are in series. In series connection, current remains same. But still, you just concentrate on your basics at the initial stages. Fine. I'll add all these three resistors. So another 24 plus 14, 38 ohms. Right? Try the lever again.
Yes, sir.
Okay. ಈ ಬ್ರಾಂಚ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಗೊತ್ತಾಗಬೇಕು ಹೌದಾ? So ಇಲ್ಲಿವರೆಗೆ current, this is an energy source which will produce current, right? Say I dash is the current, total current. These two are in parallel, correct? These two are in parallel, hence current will divide into I1 and I2. Let us say I1 is current through 10 ohms. I1 is the current flowing through 10 ohms. We don't require I2. I2 is the current flowing through 30 ohms, whereas I dash is the total current of the circuit. So what I do, in order to know the current, we know the voltage, but current is unknown. So if I evaluate total current of the circuit, then by applying current division rule, it is easy to find the current through this branch, correct? Okay. In order to find out the total current of the circuit, first we should know the total resistance of the circuit. Let us simplify. Now 38 ohms and series combination of all these three are in parallel, correct? So 10 to 24 ohms and 38 ohms are in parallel. Simplify. This is 4 ohms, 10 ohms. ಎಷ್ಟಾಗುತ್ತಾ 38 parallel combination of 38 ohm and 24 ohm.
14.7 ohm.
14.7.
7.
And here there is 4 resistor plus 10. Now the circuit has divided into a simple loop or a simple series circuit. Correct? So now I can easily calculate the total current. Let me call it as I dash because I have taken its notation as I dash. So the same current I am going to assume. I dash will be the total current. How to find total current? Simple Ohm's law. V by R. 180 upon total resistance of the circuit is all the three are in series. 10 plus 4, 14, yeah,
28.7.
7. What is the total current? Total current of the circuit?
6.27 amps.
27.
This is what? Still the problem is not yet completed. We found total current, I dash. I'll do reverse engineering. I'll come in reverse. Right? These are the steps which I made use to evaluate total current. Right? Now I came to know the total current of the circuit as 6.27 amps is the current flowing here. Correct? This current will divide into two branches because both are connected in parallel. Once again, these two currents will enter at this junction and the same current 6.27 will flow through 10 ohm. Right? In over a loop, current will be same. Since they asked us to find out current through 10 ohms, let us evaluate current flowing through 10 ohm. That is taken its notation as I1, which is equal to how rule apply ಮಾಡಬೇಕಿಲ್ಲಿ? If I know the total current and two branches in parallel, current division rule, correct? In order to know the current through this branch, in opposite resistance is 38 ohms upon total resistance. 38 plus 24. Start. Multiplied by total current, that is 6.27 amps. ಮಾಡಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ.
.84 amp. 84 amp.
amps. This is
84 amps.
going through 10 ohm resistor. This is the required solution. Current flowing through 10 ohms is 3.84 amps. Exactly. Okay, till now we solved only DC network, I mean only resistive network. Alright. In the next class, we'll solve one or two examples by taking AC circuits. Keep calculators along with you because it is a bit difficult to calculate manually for complex numbers. Okay. So keep your calculators ready for the next class. Today I'll stop here. We'll meet you in the next class.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.